Hi everyone, just welcome to a new video. So today we're going to train a neural network. We're gonna train a computer vision problem, simplest problem on computer vision that you can find, and we're gonna do it on Databricks, as we can see. So first of all, I have in here the notebook that we're gonna run. Make sure that you have your compute cluster ready, because I needed to just create a new one, because we are on the community version, and whenever you just go beyond the usage of it, you just have to create a new one. So the first step is going to be to install the dependencies, and it's going to start it right here because it's going to take some time. We select, attach, and run. Yeah, it's going to take some time. And whenever the dependencies are ready, we can just go to the next step. So just to clarify, we need MLflow, PyTorch, Torch Vision, then Matplotlib to provide some examples of the dataset, and NumPy. That's all the dependencies. We're gonna leave it there. So the first step is gonna be to import all the dependencies to make sure that we link the execution of the run to the experiment that we have, and then we autolog everything that it contains and we start the run. Okay, that's all we do in this cell. On the next cell, we download the data, we create a directory folder called data, and that's going to contain both the train and the test set, and we're going to have them separated, data loader from PyTorch, and this is going to permit us to train on the training set and then to check how the model is on the test set. This is going to take some seconds. This is quite fast. This is the Cypher 10. We have 10 classes. That's basically the problem. And we have pictures. And we need to make sure that the pictures are categorized or classified as the right class. Then we're going to visualize some data. We can already see how low quality the images are, as you can see. That's on purpose. That's a very old data set. That's a very old test problem that appeared possibly around 2013, 12, 2014, something like that. Maybe this wrong, and it's much older. I'm not sure, but that's around the time that it got famous because CNN's convolutional neural nets were starting to boom. Different architectures were being tested, the AlexNet, GoogleNet, and many others. And because of that, this got quite famous. And pretty much every year there was a contest to see which neural network could improve on the previous best results. We're gonna create the neural network right here. This is gonna be a simple CNN. It doesn't have much convolution, pooling convolution, and then 3 linear layers, something quick, something that you can train on the CPU in a quick manner. And then we train the network. That's something interesting to cover. This is pretty much something by default because you're gonna use cross entropy loss because you are doing classification. Then you're gonna use SGD. We could use others like Adam, NADAM, or weight decay with Adam, whatever. But we're gonna go with this. These are the simplest. And also SGD is the one that uses pretty much the least amount of memory. Possibly there are more optimizers, but this is one of the ones that uses the least or pretty low amount of memory resources. And then we start the run. We're gonna log the different hyperparameters, the learning rate, momentum, the epochs. We're gonna train for 2 epochs, and then for each of the epochs we go through one batch of the train loader. The batches are gonna be for 2000, if I'm right. Yeah, right here. And every 2000 mini batches, sorry, we're gonna plot what's the loss that the model has, and we are expected to see it going downwards. So that it's gonna train. So the lower the better, basically. And then we're gonna log also the loss that we receive on each of these 2000 epoch or mini batches. and then we lock the model. So this is something necessary because otherwise you're not gonna be able to save the model. This is something necessary because otherwise you're not gonna be able to see what the progression was. And then whenever we are finished, we just save the model. This is not something necessary because we are doing it with MLflow, but if you didn't use MLflow, that's how you save the model. And finally, we test the model and see that it works as expected. So just finish this part in here. Let me just go for the import. So it was 4 minutes to install everything. We're just gonna start this experiment. Already done. We're gonna download the data. It's not gonna take much time. And as soon as this finishes, we can just visualize some data. Alright. So this is a cat, this is a cat, this is a dog, this is, I don't know. Well, this is a bird. There you go. And basically, we're gonna create a neural network. Done. And we're gonna train it. It's gonna take 2 minutes, around 2 minutes. It's already active. To start a new run first, and okay, this is something that could happen. So MLflow and run, and I'm gonna explain you guys what pretty much happened in here. So if you leave an execution and oh no, sorry, I know what happened. We are starting the running here. We shouldn't do that. That's bad. Because I have improved and I have moved this start on a different line. So what I'm gonna do is I'm gonna end first, then just run the start. But this is not something neat. Make sure that that doesn't happen to you. I'm just gonna remove this and leave it as it was. So it is running at the moment. We're gonna see here the updates as they appear, and until that ends. So we are running on CPU. We can check the results, and let me clean up the previous one that was failing. Well, not failing, but it wasn't proper because I wasn't doing anything. So this one go doesn't have anything. It's empty. It doesn't have parameters. Doesn't have models. Nothing. So I'm just gonna delete it. And I'm also gonna delete the first one because I think it didn't contain anything. Yeah. Because I didn't have the MLflow code. So yeah. This is the previous execution, I guess. Well, this is the actual one that's running, and this happened before, and this was the result, 0.97, the previous one. This is the model that we can use. We cannot use it because we are on community, but if you pay for Databricks, you can use it. And this is the source, the notebook that was used, so you can trace back the code that made this model. And then we have the epochs, learning rate, momentum. If we added different parameters, those could be just being described as they were. This has not finished yet, but this is the latest, so you can see it on real time how much is the loss. So if it is a training run that's gonna take hours, you can just follow up, and you can also see it on here. Even though it has not finished yet, it's still running. So this will update from time to time. You just can forget about everything, just come in here and see how it's doing. Or you can just check it on here. It's gonna end pretty soon. I think there's one more, the last 20k, and that 12k, and that's gonna be it. Yeah, there you go. So one more data point in here, I guess, and that's gonna be still running. Okay, we are finished, and now we can also save the model manually, and we can test the model. So let's see what happens. This is a cat, this is a zip, this is a zip, this is a plane. It works perfectly fine. Let me add more, just to have more fun. Oops, sorry. What if I do this? Yeah, I don't know. I don't know how to sense this code, but it seems to work. So yeah, whatever. The results were correct at first. Cat, zip, zip, plane. So this is pretty much it. I'm just gonna check that we have everything finished, that we have them all linked. Yeah, it took 2 minutes and a half. We can compare them. If we come in here, we can check the differences, right? And we can also click on each of the models, and it's gonna bring us to the model itself. This is the artifact of the model. This is how to run the model on inference. We have an overview, we have the metrics. This is how the loss evolved in the previous run. And then we have the artifacts. So we have the requirements that you need to install for this to work, how to create this with Conda, and then the data that we use, the model, and the metadata, whatever it is. So I hope you like how to train a PyTorch model from Databricks. Hope you, if you have any questions, just let me know. Like, subscribe, click the bell button. See you in the next one. Bye bye.